Hello, I'm John Callender. A few years ago I made some videos about sea level rise in Carpinteria, and there's been some developments recently, so I thought I would make an updated video. A quick disclaimer, I'm a member of the Carpinteria Planning Commission and of the city's General Plan Update Advisory Committee, but the things I'm talking about in this video are my own personal opinions. They don't necessarily reflect the views of the city or the Planning Commission or the Update Committee. To understand where we're at in Carpinteria in terms of the issue of sea level rise, I think it's important to understand three things. So that's what I'm going to talk about in this video. And those three things are the map, the curves, and the timeline. So let me get started and talk about the map. Here is a map. This is not the map, but it's a map, and it'll help get us oriented. This is a map of Carpinteria. Here's the 101 freeway, Carpinteria Salt Marsh, Carpinteria Bluffs, sort of the downtown area in here. Linden Avenue comes down here and meets the beach right here. So here's a zoomed in version of that map. This is Linden Avenue coming down to the beach, the railroad tracks, Sandyland Road along the beachfront, Ash Avenue kind of goes past the marsh. This neighborhood here is really important in terms of understanding the issue of sea level rise in Carpinteria. This is the beach neighborhood. So this still isn't the map, but this is the map that I really want to talk about. So this is that same area we were just looking at. If I back up, you can kind of see it's same area, but now the structures have been color coded. And what this map is this is, I think, one of the most important parts of the city's vulnerability assessment that they came out with last year. This is a report that the city of Carpinteria created with a grant from the Coastal Commission. And it's a lengthy report with a lot of good information, and I certainly encourage anyone who's interested in this issue to read it. And it's very readable, but it is large. If you're just going to look at one thing in the report, though, I would say to look at this map, because I think this is key to understanding the issue of sea level rise in Carpinteria. And again, it shows the beach neighborhood with the structures color-coded according to how vulnerable they are to different amounts of sea level rise. So if you look here, along the beachfront, the south side of Sandyland Road, these structures are in purple, and that represents structures that are vulnerable today with no sea level rise at all. And one important thing to mention about this is this map looks at vulnerability without taking into account any kind of protective measures. So it doesn't talk about, for example, the winter beach berm that's constructed south of these homes for about 6 months out of the year. Basically, the city of Carpinteria takes bulldozers and pushes up the sand into an artificial dune. And the idea is to protect these homes from winter storm waves. In previous years, when that berm was not constructed, there has been damage from winter storm waves to the structures here along the south side of Sandyland Road. So that confirms the analysis here that shows them as vulnerable even today. Then if you add 1 foot of sea level rise, these red structures become vulnerable. And when I say vulnerable, there's several different kinds of hazards that the analysis looked at. There was storm waves coming in off the ocean. There was high water events from like high tides, extreme high tides, and then storm events where you get a lot of rainfall and the water level rises. And especially, when you combine those things, which tends to happen, you get these very high water events and the potential for flooding. And then at 2 feet of sea level rise, you get these orange structures. And at that point, you can see that a large majority of the beach neighborhood is facing an extreme flood risk. And the authors of the report identified that 2 foot level as an important tipping point. And then at 5 feet of sea level rise, which is the last elevation that was modeled here, you get basically the rest of the beach neighborhood, and then you start to involve areas north of the railroad tracks as well. So when you look at this, one thing that comes through pretty clearly is that sea level rise really has it in for the beach neighborhood. And the reason for that is kind of interesting. If you look in Google Maps, you can kind of see why that is. So here's the railroad track. You can see as it comes up the coast, it's very close to the coast, and then right here, this is in the State Beach campground right around Carpinteria Creek, it diverts inland. Well, the reason it diverts north there is that when they built that railroad line around 1900, this was all salt marsh. The salt marsh didn't stop here. It continued east all the way to the mouth of Carpinteria Creek. And when it was developed over the course of the 20th century, the developers brought in fill dirt and raised the ground level above the high tide line in the marsh and then built on it. And fill dirt is expensive. They didn't want to spend their profits building it up any higher than they had to. So this beach neighborhood is very flat and very close to the high water level. So that explains why just a small amount of sea level rise starts to create serious flooding problems for it. That's part one. Let's go on to part two, which is the curves. This is a table from the city's vulnerability assessment, that report I was talking about that the map came from. So what this table shows is current best available science about predictions for future sea level rise. There's a lot of numbers and it's kind of confusing. I think it makes a lot more sense if you plot it as a graph. So these are the low emissions scenarios. The scientists who study climate change and sea level rise don't know for sure. Even if you tell them what future scenario we're talking about in terms of emissions, there's still a range of different possibilities that they foresee for how likely it is that there will be different amounts of sea level rise. So in this optimistic scenario, low emissions scenario, they believe there's a 5 out of 6 chance we'll get at least this much sea level rise, a 1 out of 2 chance, 50%, that we'll get at least this much sea level rise over time, a 1 in 6 chance, or 17%, that we'll get this much sea level rise. And you can see I've added this dashed line here. This corresponds to the 2-foot level. So this is that point where the beach neighborhood is in major trouble. And you can see that if we assume the low emissions scenario, and we assume that we're somewhat unlucky, right? If you roll a die in a board game and, what are your chances of rolling a 6? Well, it happens. It doesn't happen all the time, but it definitely happens. If we rolled a 6 in terms of future sea level rise, if we were in this upper 17% of probabilities, we would come in at 2 feet of sea level rise right around the year 2100. And then there's, higher paths for the 5% scenario, 1 out of 20. And finally, this significantly higher path for the 1 in 200 probability, the 1/2 of 1%. I'm not going to spend any more time talking about the low emissions scenario. I would love to believe this will happen and all the governments of Earth will come together and collaborate on reducing their greenhouse gas emissions dramatically and quickly. But I don't think it's likely. And I think if we're being realistic about preparing Carpinteria for the future we're actually going to live in here, that we should look at more realistic scenarios. That brings us to this. And these are the curves. I talked about, the map, the curves, and the timeline. And these are the high emission scenario, the sort of business as usual scenarios. And this is what the experts think we can expect in terms of future sea level rise as of particular points of time in the future in Carpinteria. So they're the same percentages we were just looking at. The 83% probability, the 50% probability, the 17% probability. But you can see, if you look closely, that the graphs are significantly higher. In that high emissions scenario, especially once you get out 40, 60 years in the future, we're getting significantly more sea level rise than we were in those optimistic scenarios with rapid reductions in emissions. Again, this is the 83% probability, the 5 out of 6. We're very likely to be on or above this line. We'd have to basically roll a 1 on our die to come in at this line. But if we do, that's great. And in that case, we would be right about at 1 foot of sea level rise as of 2100. Then this orange line, this is the 50% probability. So you can imagine it as, well, if we roll a 4, 5, or 6, we'll be on or above this line. 1, 2, and 3 will be below this line. So it's kind of right in the center of our probabilities, the likely future probabilities. And in this one, we reach 2 feet of sea level rise a little bit before 2100. So I think that's a very important factor to keep in mind. It's not a super unlikely scenario that beach neighborhood will see 2 feet of sea level rise by the end of this century. In fact, it's a pretty likely scenario. That is the future that our descendants who are living in Carpinteria at the time are likely to be experiencing. They may get luckier, it may be less than that. They may be unlucky and it may be more than that. But if they're right down the middle of the currently projected probabilities, that's where they would be. And then this 17% probability, this is sort of the statistical flip side of this lower curve. This is the one that says, there's a 1 out of 6 chance that will be this high. So this is like if we get unlucky and we roll a 6 on the die, this is where we're going to come in. So up here, you can see we actually hit 2 feet significantly earlier. We hit it, before 2080. So, a little bit of being unlucky, and we're hitting that point where the beach neighborhood is having serious flooding as soon as 60 years from now. Then the 5% probability, or 1 in 20, again, substantially earlier still. So we get to about 2070 when we hit 2 feet. The 1 in 200 chance, quite a bit earlier. We're here at a little, like the early 2050s. We'd be at 2 feet of sea level rise in that scenario. And again, not a very likely scenario. So we probably are not going to experience that. But I think as we're thinking about flood safety for our descendants, we should think about, okay, well, they might experience that, and can we make good decisions in our planning that gives them better options if in fact that happens. So let's talk about this last curve, this highest curve. This is called the H++ scenario, and this is kind of a worst case scenario. Over the past few years, there's been some new research that shows there's a possibility, according to the scientists who study things like this, that there could be very rapid melting of land ice in places like Greenland and especially Antarctica. And that gives you very rapid sea level rise. They don't know enough about it to know how likely it is. I think the sense I get from just being a layperson reading the descriptions of this research is that, well, it's very preliminary. They want to do more research, but it's enough to make them nervous. And so in this report, this OPC 2018 report that, again, the state authorities say we should use as the basis for our future planning, they include it there as a low probability with no actual probability number assigned to it. They don't even say this is like, this is 0.05% probability. They don't know. They just say, well, if this happened, we would be surprised. It would be, very unusual, but not impossible. Like they see a mechanism where, it is possible that this could happen. And of course, they'll do more research, and, hopefully this picture will get clarified going forward. But it is out there as just something to be aware of, that there is a chance that we would be in that future, in which case we'd be at 2 feet of sea level rise by the 2040s. So, and then we would go on considerably higher from there. So again, probably won't happen. We're probably in, one of these scenarios down here. And in fact, you can see I've shaded this area with blue shading. This refers to the sort of likeliest central probability. This is the central 2/3 probability. There's a 1/6 chance we're below this blue shaded area. There's a 1/6 chance we're above the blue shaded area. But there's a 4 out of 6 chance, or a 2/3 chance, that we're in somewhere in that blue shaded area. So if you think about what's likely, we're likely in somewhere in this shaded cone here. So now you know about the map and you know about the curves. Let's talk about part 3. Let's talk about the timeline. If you're like me and you look at the map and you look at those curves, it's concerning because you can see that we may be getting into real serious flooding issues in Carpinteria this century, and in some of the very unlucky scenarios as soon as just a few decades from now. So we should have a plan for that. And again, the city's vulnerability assessment includes also extensive information about different options for what we might do. And those options fall into several categories. So I want to talk about those briefly. The first category, and the first thing that people tend to do when they face an assault from rising seas, is protection. Things like seawalls, or the winter beach berm, sort of a softer version of a seawall that's only there half the year. But the idea there is you put up walls and you stop the ocean from coming in and messing up your structures. There are a number of problems with protection. It's expensive, and it tends to become much more expensive and much less effective as sea level rise progresses. So it's useful early on, but then it becomes less useful. For that reason, as we get to 1 foot, and especially as we get to 2 feet of sea level rise, protection isn't really going to help us with the beach neighborhood. It's just not going to work. So that leads us to the next category of things you can do about sea level rise, which are sort of broadly grouped under the term accommodation. And the idea here is, okay, we're not going to be able to keep the rising sea out of our neighborhood, but we can make changes to make the neighborhood more resilient and less prone to, big disastrous problems. Building standards that make the homes be elevated higher than they otherwise might have been built. Or even in an extreme case, you could say, build your homes on stilts. Have a first story that's just pylons and all the living areas are up on the second story. Different kinds of things you can do in terms of accommodation. And, clearly as sea level rise takes effect in that beach neighborhood, we will be doing lots of accommodation type things. But again, as with protection, as the sea level rise increases, as we get up to higher levels especially, those accommodation measures become more expensive and less effective, which ultimately means you end up at the last adaptation strategy, which is to retreat. So I think if we're being honest about the information in the city's vulnerability assessment, there's really no escaping the conclusion that some kind of retreat process is in our future. And given that, I think we should plan it. In a military context, if you see an enemy coming with superior forces that you can't defend against in your current location, if you recognize that soon enough, you can redeploy your forces. You can pull back to a more defensible position. If you wait, though, if you wait too long, it becomes a lot harder. The faster you have to conduct your retreat, the greater the chances of it turning into a rout with heavy losses and having to leave things behind that get destroyed. And so as a community, I think it's very much in our interest to have the foresight to recognize the need for this coming retreat and to plan for it. So let's talk about that. What are the steps in a managed retreat? The first step, I think, would clearly be some kind of moratorium on new beach neighborhood development. We don't build in the path of flooding. We don't build today on the salt marsh because it would be foolish. Your structure would be destroyed by floods at the next high tide. By the same token, if we can see that flood waters are coming, let's stop building structures that have a life of 75 or 100 years in the path of that flooding. So that's step one, is a moratorium on future development. The next step would be to restore the Sandyland Road shorefront to a coastal dune. And again, these are those structures that are in purple in the map. These are the ones that are at risk of wave damage and storm damage even today, such that we build the beach berm every winter to protect them. If we remove these structures and restore something like this coastal dune system that existed before they were built, we can get a lot of protection. And what it does is it buys us time to complete the retreat for the rest of the neighborhood. If we can get a nice dune system in place here, we can protect the rest of this beach neighborhood as we go up to 1 foot of sea level rise and beyond. And it gives us time to empty it out before we get to 2 feet. This would be the first piece of restoring what gets referred to as a living shoreline, a natural, low-lying coastal environment that is actually very good at protecting the area behind it from things like winter storm waves and high water events. And then the final step is to empty out the rest of that beach neighborhood and restore it to a coastal estuary. A coastal salt marsh is actually a great technology for protecting a community from high water, flooding, coastal storms. It floods every day with the tides. It's pre-adapted to flooding, and it will absorb water. It will keep that water away from homes. So there are the 3 major steps in a successful managed retreat process. The only thing we need now is to know what dates to put on here. How fast do we need to do this? So here's a version of the managed retreat process that assumes that we're on this 50% probability, right down the middle of the likeliest scenario for future sea level rise under the high emissions scenarios. This gets us to about 2 feet of sea level rise around 2100. It assumes that we start this process essentially immediately. We then have 40 years to get to having that shorefront restored to a coastal dune, which we would get done, prior to getting to 1 foot of sea level rise, so that would work. And then another 40 years to get the rest of the neighborhood emptied out and the coastal estuary restored by 2100. And to me, that seems quite doable. We could accomplish a lot of that just with attrition. Again, if we stop doing new development and redevelopment in that neighborhood relatively soon. those structures will be old and falling down, and it'll be time to clear them out when they reach the end of their useful life. But let's say we're unlucky. Let's say we roll a 6 on the die and we're up here on the 17% curve. In this case, we need to get there by around 2080. Okay? So now we've got significantly less time. Now we've got 30 years for each of these steps. And that gets harder. Right? And that sounds like a lot of time in one sense, but this is a big project. Now we're in a scenario where we're talking about more sort of stranded assets, more existing properties, existing structures with useful life left in them that we have to figure out a way to get them out of that neighborhood regardless because the floods are coming. Let's say we're really unlucky. Let's say we're in this 5% scenario, 1 out of 20 chance comes through, or some, version of that H++ scenario, maybe not the full thing, but enough that we're up here on this yellow curve. Now we need to get that beach neighborhood emptied out by about 2070. So that's significantly sooner. Now we've only got 25 years for each of these steps. And now I want to talk about the thing that I'm actually most worried about in the short term, here and now. We're in this process now of updating our general plan. And this time we're doing it, bringing sea level rise science into the planning. We're trying to, do a good job of figuring out what are we going to do going forward. There is a risk that we will in effect kick the can down the road. If we decide to, in essence, put this off, if we decide, we're starting the process, we've made progress, that's enough for now, let's wait until the next general plan update in 2040 to address some of these harder issues that might get us into, difficult legal territory or contentious discussions with property owners about the values of their beach neighborhood properties. Let's put that off till the 2040 update. Now our timeline looks like this. Now we're basically saying we're going to allow continued development to happen in the beach neighborhood, losing some of our existing adaptive capacity because we're losing the benefit of having those older structures there with less valuation. We could be looking at a very difficult situation that we'd be handing off to the next generation of Carpinterians who are going to have to deal with this, where they would need to try to do a 15-year conversion to get that coastal dune restored, and then a 15-year conversion to get the rest of the beach neighborhood emptied out. That to me sounds very hard. So that's it. Here are some sources for more information if you'd like to read up on this. There's also a link to my previous videos about sea level rise in Carpinteria. Thank you for taking the time to learn about this, and I'll talk to you later.